Добрый вечер. Добрый вечер. Мы приветствуем вас в арт-пространстве Артемьев. Это конференция «Архивация настоящего». И ее второй вечер — это будет встреча с Максом Брюкером, инженером, который долгое время работает в французской студии «Граммы». И сегодня наш вечер будет построен таким образом, что вначале я хотела бы немного рассказать о студиях, которые работают активно во Франции и известны своим исследовательскими интересными подходами к электроакустической музыке, и представить Макса Брюкера, а затем он присоединится к нам в Zoom и расскажет о своей работе. Это инженер с очень большим опытом работы с современными композиторами, и, в общем-то, в ЦИАМ тоже были вместе с ним реализованы многие пьесы и российских композиторов, и зарубежных композиторов. Можно было их услышать на разных наших концертах и на фестивалях. И дальше будет секция с вопросами, где любой желающий сможет спросить Макса Брюкера о том, что вас интересует. Вопросы можно будет задавать на русском языке, я попробую их перевести на английский, и вся встреча будет на английском. Также мы будем рады вопросам и в трансляции. У нас открыт чат. Если вдруг вам захочется задать свой вопрос, то вы тоже сможете это сделать. И история студии, она ведет свое начало со второй половины XX века. Это такая устрашающий разворот страничек из книги Тома Холмса, который показывает вообще количество разных студий, которые появлялись в Европе после Второй мировой войны с 50-х годов по 60-е годы. Эти студии, как правило, появлялись на радио, и радио становится главным таким пространством для творческих экспериментов. В том числе такая первая знаковая студия, она французская студия. И, как вы видите, кстати, здесь много представлено разных стран. Здесь и Германия, и Франция, и Италия. И даже есть в качестве примеров Советский Союз, представленный экспериментальной студией электронной музыки, которая располагалась в музее Скрябина. Это тоже такой, наверное, единственный прецедент в Советском Союзе, когда существовала такая экспериментальная лаборатория электроакустики, и в ней работали композиторы. Потому что вот здесь, в Московской консерватории, тоже существовала лаборатория, но там композиторов не было. И это, наверное, главный минус этой лаборатории, потому что лаборатории и такого рода экспериментальные центры, они невозможны без творческих проектов и без участия композиторов или художников. И в этом смысле Мурзин, который создал и свой инструмент АНС, и способствовал организации этой студии, он, конечно, еще сделал очень правильный шаг, инициировав вот такие творческие резиденции фактически для композиторов, чтобы они могли работать с этим инструментом и писать музыку. И, собственно, поэтому именно этот синтезатор, этот инструмент получил такую популярность и такую востребованность. Но вернемся к истокам студий. Студии еще распространялись, первая их волна связана с такой докомпьютерной эрой и с работой с пленкой, с магнитофонами. И в данном случае вы видите первую знаковую для Франции студию «Жерем». У меня здесь в расшифровке названия даны на английском. И вот год ее возникновения, 1951. Это такой рассвет экспериментов с пленкой. И здесь вы видите на правой картинке фотографию Пьера Шеффера, одного из основателей, очень ярких представителей электроакустики, который сидит с огромными бобинами и с огромным количеством пленки, своим таким рабочим инструментом. И вы, наверное, еще знаете, конечно же, студию, даже не студию, а целый институт, ИРКАМ. Это уже следующий виток развития студий, потому что он связан уже с компьютерной музыкой. Компьютерная эра, она буквально начинается, да, с конца 60-х, появления каких-то первых мощных устройств. И вот как раз РКАМ фокусирует свое внимание на развитии компьютеров и на внедрении компьютеров в творческую практику. Возникновение РКАМа связано с 1969 годом, концом 60-х годов, и такой культурной революцией во Франции, и, конечно же, с деятельностью композитора, дирижера Пьера Булеза. Пьер Булез и многие музыканты и композиторы до этого работали и в ЖРМ, и сотрудничали с Пьером Шефером. Но вот РКАМ открыл новую страницу в этом мире студий. РКАМ, да, и как и ЖРМ, это такие комплексные центры, которые занимаются очень разными областями деятельности. И там есть, конечно же, опора на творчество, огромное количество творческих проектов, резиденций, фестивалей, каких-то отдельных концертов. И, с другой стороны, разработками, которые необходимы для этого творчества. То есть исследовательской работой, как вы видите, для французских центров характерны разного рода сложные аббревиатуры, которые подчеркивают вот эту разнонаправленность действий центров или студий. То есть это, конечно же, исследовательская работа, разработка программ, которые нужны для творческих экспериментов, музыковедческие, можно сказать, исследования и, конечно же, акустические исследования. Плюс РКАМ — это такая мощная образовательная платформа для молодых музыкантов. И здесь есть большой фестиваль «Манифесты», который объединяет вокруг себя не только вот такую программу концертную, там, возможно, инсталляции, выставки, но также параллельно с этим идет программа образовательная, куда могут подавать заявки очень разные студенты. Это могут быть и композиторы, и инженеры. Это могут быть музыканты-исполнители. И, в принципе, там еще есть круг слушателей. И, наверное, как раз программа слушателей вот в РКАМе тоже особая, потому что слушатели могут делать свои презентации во время фестиваля. То есть они могут представлять какое-то свое творчество или, например, свою исследовательскую работу. И они из статуса просто слушателей этих событий, они становятся вот такими участниками и могут обрести много новых знакомств в результате вот такого сотрудничества. Еще важным моментом, наверное, в истории композиции и в работе студий обнаруживается то, что теперь вот композиторы работают в связке с инженерами, потому что и в ЖРМ Пьера Шефера, и в разных студиях, неважно, немецких или итальянских, оборудование было очень сложным. Да, сегодня это просто портативный компьютер, и можно даже не выходить из дома, чтобы создавать очень сложные произведения и производить различные эксперименты в области электроакустики. А тогда, в общем, требовались довольно долгие и расчеты, и длительное время для того, чтобы реализовать те или иные действия. И, в общем-то, тут этот процесс он был невозможен в одиночку. И поэтому и в известнейшей студии в Кёльне Карл-Хайнц Штукхаузен, да, очень много работал с инженерами. И в центрах, которые мы обозначили, тоже встречается вот эта связка композиторов и инженеров. И это такое полноправное сотрудничество, о котором, я думаю, что лучше расскажет уже сам Макс, потому что у него колоссальный опыт работы с композиторами. И здесь, наверное, у ассистента и у инженера у него есть такая самостоятельность, и очень важно, чтобы это был соавтор композитора, а не просто человек, который может помочь реализовать те или иные идеи. Вот я думаю, что сегодня будет уникальная возможность спросить у Макса, как этот процесс внутри организован. Как я уже говорила, Макс Брюкер работает в такой студии в центре большом, который называется «Грамм». Он тоже имеет большую историю, потому что он был основан в 1982 году и на сегодняшний день является таким национальным центром исследования электроакустической музыки. И этот центр располагается в Лионе и тоже занимается, как вы видите, тут опять очень сложная аббревиатура, в данном случае она вот расписана по-французски, и тут можно заметить, что опять-таки это такой, даже тут довольно интересное слово, первый генератор да, разных проектов и в области музыки, да, и исследований, которые здесь проходят. То есть это очень важная точка для развития электроакустической музыки, которая располагается в Лионе. Сегодня, когда компьютеры уже портативны, да, и композиторам нет необходимости выходить из дома, чтобы что-либо написать, им не нужно какое-то колоссальное оборудование, как во времена Булеза или Штокхаузена. Все же вот эта связка инженера и композитора, она остается очень важной, потому что все равно это какое-то сотворчество, и технологии, как вы понимаете, очень быстро меняются, и не всегда можно за ними успеть. Поэтому вот студии не потеряли своей актуальности. Прежде всего, да, это важные такие резиденции для композиторов и место, где все же возможны такие большие эксперименты, потому что электроакустическая музыка еще очень связана теснейшим образом с пространственным ее воплощением. И вот на нашей финальной встрече 14 ноября вы сможете подробнее узнать как раз о пространственной составляющей звука из презентации композитора, исследователя Паула Шагаса, который как раз разбирает разные подходы к звуку и его представлению в пространстве у композиторов Германии и Франции, у инженеров Германии и Франции, то, как они понимают звук, его воплощение в пространстве. Поэтому вот этот разговор, который мы начинаем здесь с Максом, он как бы будет иметь еще вот такое продолжение в эту пятницу. Ну что же, я сейчас, наверное, буду уже переходить к нашему разговору с Максом Брюкером. Он композитор по образованию, и у него еще есть такой неакадемический бэкграунд, потому что он участвовал в юности в очень многих группах экспериментальных и играл музыку в диапазоне от джаза, рока и какой-то экспериментальной электроники, и он выступает как импровизатор. Но, как я понимаю сейчас, он много занимается такими real-time процессами в композиции и в создании таких мультимедийных произведений. Ну и об этом, наверное, мы поговорим. И главным образом он разберет разного рода патчи, то есть техническое воплощение пьес, и покажет, как он работал над теми или иными задачами в разных сочинениях и с разными художниками и композиторами. Так, ну что же. Сейчас мы подключим Zoom.
Hello. Can you hear me?
So, good evening, Max.
Good evening.
Can you hear us?
Yes, I can.
We're so glad to see you here at our conference. It's a great pleasure to have opportunity to talk to you and to know more about your work experience. So you can start your presentation.
Thank you. Thank you very much for having me. Hello, everyone. My name is Max Brüker. Probably I've been introduced a little bit and you talked about the contemporary centers in France. There are many other contemporary centers in France than the one I work with, which is actually GRAM, that is based in Lyon. So just to explain what I am and who I am and what I do. I am an electronic musician. I studied composition many years ago, classical composition, instrumental and electronic composition. I am a former electric guitar player. And because I was bored by playing only with my guitar pedals, I started playing with synthesizers to see how it works. And then I switched to electronics, deeper electronics, because synthesizers were not, sufficient enough for my needs. I still work a lot with synthesizers. And with that knowledge, I've developed different techniques of sound engineering and producing music. So I am a composer. I am an electronic musician, you would say. I perform on stage. I help other composers create their own music, which is a thing I'm kind of known in France and abroad, because I help them do their max patches or do their different techniques. And I'm a trained sound engineer because I also mix and master a lot of classical music, which is one of my strong suits too. So this all together makes a very small, very strange, set of skills that's kind of, it's not composition, it's not musician or instrumentalist, or sound engineering only. It's all together. And I would say I'm more of a hacker in the way that I perceive things and the way I do things. It's mainly because I'm not a scientist. I'm not a searcher. I understand C++ programming and hardcore programming, but I'm not really skilled at it. So this is basically why I switched on to Max very simply, because it looks like a modular synthesizer, things that I've known in the middle of the 90s. I was already working with synthesizers then. And this is what we learned that in school, in music school. And so along the years, I've used that a lot to develop some things. And in the very beginning, I started working with, which sounds really old school, Max 3.4. Now it's Max 9. So that was the very, very beginning of Max. Some people might know it, but it was mostly done for MIDI, very little DSP inside. And now, because the computers have been developing so well, I've developed a huge language for DSP processing, which has turned into some sort of complication along the years because techniques have changed a lot. And the whole talk is about how, the way I try to manage to keep up with technology changing in Max MSP in particular, but also everywhere. I mean, what are my methods in that field? Is it clear for everybody, or am I going too fast? It's okay. Okay, perfect. So one thing I must emphasize is that I'm probably very old school in the way that I work. Is that I sketch, I do a lot of drawings, and I take a lot of notes. First thing I do, because I like to draw a lot, and there are magnificent tools that appeared now, like iPads and touch screens and pencils and things like that, where you can sketch very easily an idea, and just have a PDF, make a PDF. So this is kind of really interesting because it's the way that I tend to write my electronic ideas, and I'm going to talk about something afterwards, but by building ideas, and I will keep track of it. Just like you will have a score, that writing electronic music is a kind of a big complication now, because it's been many years that electronic music exists, and we have lots of difficulties to write it down properly. So instead of trying to figure my own language, what I do is I try to describe it, and I'm using techniques that you might meet in the field of scientists, meaning the more description you have, the better it is for everybody. So drawing is kind of for the way that I do things, and I produce a PDF out of that, and I always attach my PDFs to the max patches that I do. And the PDFs can be many things, and this is the other side, because as I told you, I consider myself as a hacker. I have part of my degree, I have a degree in engineering, which makes me a builder. I mean, I work a lot with 3D printing, a lot with sensors. I build my own sensors. I build my microphones. I mean, I build the things that I need. And this is very, so I try to apply things that's used in engineering to music. And I will try to describe as fairly as possible what I'm doing. And recently I've been working on a noise box. If you don't know, you guys know what a noise box is. It's a sound design tool. It's an acoustic instrument with microphones inside. It's basically a box with springs and pieces of metals and things that you can scratch and you can pull, you can hit, and it makes these weird sounds. And sometimes it depends what you're using, but if you're using wood and a bow, it will sound like a cello that's being, bowed on the side. It could be, you get very close to these things, you could have metal sounds that would sound like percussion, which is kind of interesting. And I've been building this using 3D printing and laser cutting too, laser cutting wood. And I've started to make it mechanical. I've put solenoids inside so it will hit, and all these solenoids will start to hit the strings, hit the balls, do all these things. And if I can show you, I can show you a screen. Let me show you. Oops, no, that's not the thing. There it is. I'm really bad at this thing, sharing stuff. So let me check this, if I can do this. I do lots of things and I'm really bad with computers. We happen to make it work. Oh, there we go. So let's go to that desktop. Let's go. Can I go to a secondary screen? Desktop 2. There you go. So you should be seeing here my secondary screen, what I've put some PDFs inside. So this is basically the sketch. It's a very rough thing, but this is the first idea. I draw a box with a string with some here it's sort of a monochord. Here is a spring, some bowls, some sticks, some metal pieces on the side, some wood on the other side, a piece of snare drum here, Velcro. This is a Super Bowl with inside a pickup microphone, and all these green things are pickup microphones. And so the whole thing is super amplified, and it goes into my max patch. This is basically how I start working, and I do exactly the same thing with the max patch. If I can show you something afterwards, here's a very quick sketch of an electric microphone, which is a very cheap microphone, and the way that I mounted it so it will adapt to phantom power. I have no preamp, but this thing is very interesting because I can use it to play pieces to, sort of go. I made a very small miniature microphone where I can go and pick up some miniature sounds and basically do things like Microphonie by Karl Stockhausen, which is a very famous piece where the player uses a microphone to zoom inside percussion sounds, piano sounds. And this is basically what I do with my noise box. So the combination of the noise box hyper amplified plus this electric thin is basically the way that I start working. And then I turn on to the max patches. I will show you just another sketch, which is another very quick thing I did for Alexander Schubert in September. We did this piece. I work a lot with sensors, motion sensors, FSRs, pressure sensors. I've been doing that for 25 years now. And I've built 3D axis plus complex glove, where the performer, according to the way he pressures his fingers on the keyboard, will trigger some things over Wi-Fi. And this is my first sketch, how I do the thing. So this is basically how I do stuff, but let me turn back to me now. This is basically how I sketch the things. And every time I do something in a max patch, this is attached. So this means that even if I'm gone, when I'm dead, people know what the electronics are made out of. And this idea of sketching things is important because it will continue, it will perdure, because Max MSP has been changing over years. Since 3.4 to now Max 9, there are lots of improvements and there are lots of downsides, in my opinion, and I'll talk about that later, that have made kind of complicated for the persons to work with Max, even though you have a very powerful computer. Let me tell you more about that. When I started in the 90s doing Max MSP, we were doing only MIDI because DSP was so complicated for the computer to do that we will have synthesizers and samplers to play the things. So everything was only MIDI. When we started doing DSP, basically most of the things were delay based with small buffers because the computers could not handle very large amount of data. You couldn't do FFT. And then in the beginning of 2000s, we started to have, sufficient CPU power to make FFT, to make complex cross synthesis, which got bigger and bigger and bigger. So this means that the further we go with the more interesting the technology gets, but the more CPU we're asking it. But the thing that's always been very important when you program audio is that you should have as minimum graphical interface as possible. Let me explain that to you in very clear words and show another patch. Now, a Max MSP patch. Let me open that right now for you and share that. So, desktop 2. This is my Max patch that I've been working on very recently. So you probably all see this screen with a waveform here. This is sort of a minimalistic Max patch that I've finished last week. And because for a need of another production, we wanted to do some 2D axis granular synthesis. It's basically a granulator, very simple granulator that works on multi-channel and that plays a sound. This is the sound. And this small ball, when I move it, will choose a portion of the sound and make small grains. So this being said, this whole thing, I made it, the first version, I made it entirely in Max. Believe me or not, this very simple patch costed me something like 30% CPU. And when I took out all the graphical interface, suddenly, not audio CPU, but general CPU of my machine. When I took out all the graphical interface, it fell to 2% CPU. So it means that when you hide the whole thing like this, you gain power. When you put it full screen, it uses more power. This means that the interface is eating CPU. And back in the 90s, we did the same thing. We would separate the CPU from the graphical interface. So if anything went wrong, we will just get rid of the graphical interface and the CPU will continue computing pure audio DSP. And this is still the case. I have a Mac M4, which is kind of a very, very recent machine, and it's still ongoing. And very recently, I've had some severe crashes because of the graphical interface. And the main reason for that is Juice. Juice is a piece of software in all the computers that is handling the graphical interface of all our machines. And because our machines are looking so nice, like, Mac apps or iOS apps, or, they have to look neat and nice and user-friendly with lots of view meters going around. All these things eat up CPU, and you don't want that when you're making music. You want it to calculate audio, not graphical interface. That is not very interesting. You need the minimal thing. So what I did in this patch, let me open it for you. Here you can see, this is basically a MIDI thing where I'm receiving MIDI. I have you can see agitating because I have a 2D controller, and it's actually feeding, I'm going to zoom in, this red box here. And if we open it, we should see the content of it. And it's actually JavaScript. So what I did, and this is the nice thing about technology, I'm really bad at JavaScript. I asked ChatGPT to write the JavaScript for me, and he did. So what I'm doing is I asked ChatGPT to make an interface, this 2D interface, and every time I touch my thing, let me zoom out, you should see that what it's doing, it's making some small grains and spreading these grains along 6 loudspeakers. I could make 64 loudspeakers if I wanted, because my patch is capable, thanks to MC objects inside Max, to do it. But the entire interface that I built in the first place with Max, now I got rid of that and I made it JavaScript. But why did I use JavaScript? It's because it's the less consuming and the less heavy interface, graphical interface that I found right now. And it looks like that's the one that's going to continue over time. And it's fairly easy to do. And because it was super simple to ask ChatGPT to do that, I just, prompted some questions. I made, and this interface is very simple, but it also handles panning, it handles distance. So I've embedded a lot of complex functions inside, which takes a lot of energy for Max to calculate, as JavaScript is more efficient. So I'm embedding JavaScript into Max to make it work. And then the rest is easing functions from Max. These are visual things. These are, basically buffers. The rest is only DSP. So my aim here is to say that the best way to make it work for me right now is to separate whatever is interface and graphical to very solid, let's say, programming, and have the DSP side being calculated inside Max. So I was asking myself, how could I go further with that? And for those who are really familiar with Max, there are there's one, it's been around for some time now, which is called Gen, and the other is Rainbow. These two add-ons inside Max are absolutely great for making very hardcore DSP stuff. Let me explain why. Because they are, by essence, C++, meaning that whatever you code inside that thing, you can actually export that as pure C++. Whoever is capable of reading C++, which is the lowest level of DSP calculation, which are it's the most efficient for DSP calculation, C++ would be the way to go if I had to write it. But as I said, I'm not a coder. I'm a hacker. I understand it, but I'm bad, and I want to play music. I'm not interested in, spending time coding. Some people are way better and like that. I don't appreciate that. I'd rather play the guitar if I couldn't do that, very sincerely. So the addition of JavaScript sent inside some Gen and Rainbow patches, for me, is absolutely incredibly powerful. Not only is it very powerful, but it's also portable, meaning that whatever I write right now can be done either in Max, but I can make a plugin out of that. I can make a web interface out of that. And even this, I'm going to show you something. I've been using Rainbow inside some Raspberry Pi, Raspberry Pi 5, which is actually reading something like 32 or 33 Max MSP patches, and it's handling it quite well. Let me share another thing for you. Where is it? There we go. It's another PDF. And I'm going to explain to you why it's interesting. Because you can probably see here, this is, for those who are familiar with modular synths, these are actually, I have many synthesizers. This is my small set. And my small set is made out of 3 synthesizers by this American brand called Make Noise. Well, it's really intense. It's really interesting. I like the sound of it. It's super powerful, but it was lacking effects. So what I built, you can't see it in the picture here. On the right side, I've put a Raspberry Pi with 2 analog inputs and 2 analog outputs, and I've put my max patches inside. So I have a live set where all this analog synth is sending inside digital effects in a Raspberry Pi. It's not a computer. It's actually a very small computer reading max patches made with Rainbow. And there's no graphical interface. I only use MIDI controllers to turn the volume up and down. And this is it. I can play with it. And as you can see, I'm showing you this thing because this particular setup thing that you're seeing is a setup for the show, a piece called Coffin Bubbles Blue by Raphael Sando, who's a very, very good friend of mine. And Raphael has always been performing his piece on his modular setup. And in May, he asked me to play his piece for him, to perform in Monaco, in the south of France, in a very big venue. So I had to perform with the orchestra on stage. And I don't have the same modular synthesizer than Raphael. So what did I do? I took this setup, this Make Noise setup, added some effects with my Raspberry Pi, and added some sounds, some synthesis inside my Raspberry Pi, thanks to Max MSP Rainbow. And I performed with that. And what you're seeing is the way I patch things. So as you can see, I sketched it up. Let's try to zoom inside. I don't know if I can zoom inside. Yeah, I can. So you can see that I'm actually showing where my cables are going. It's a huge mess, but because I've been sketching everything from Strega to CV out, from to there, and here's a small mixer where everything goes to. And I have a small setup, and this is actually inside my score. I have my tablet with my score, and that I read. I have my notes, but in the very beginning, with my PDF file inside my score reader, this is what you can see. So whoever is going to perform after me can actually see what I've been using, how it was connected, where I'm triggering it, because in my score I wrote, turn the volume up counterclockwise up to 1 to 2, and this is all written. So this is how I do things. I actually overwhelm people by information. It's kind of very fastidious and very long, but as you can see, some very basic information where I say, well, land to computer in SSH whenever I need it, but I'm not even using the computer on stage. It's only this setup is performing Raphael's piece, which is really great. That is absolutely marvelous. So this is one of the nice things about these new versions of Max, is the ability to make to embed JavaScript, to embed C++, to make some very efficient gen patches, and all play that either inside Max or now in a Raspberry Pi or in a very small Windows shuttle. I've seen a guy do that in a very, very small Windows shuttle this big. I mean, it's 15 centimeters large, and his Windows shuttle doesn't even have a screen. When it boots, it plays things, which is completely crazy. And let me show you another thing. Let's turn back to the Max patching, really the hardcore patching, and put this aside and share again. So what you're seeing now is, as you can see up here, it's not zooming in, but up here there are some windows, some sub-windows. This is my main Raspberry Pi development patch, my Rainbow development patch, where I'm actually, you can see my Raspberry Pi Max Pi over here is connected. It's already connected to my computer. Whatever I'm doing in my patch here is going to be sent over Wi-Fi to my Raspberry, and then there it is. And what I've done very recently, I've highlighted some parts that we find them for you. Delay. I've made some very simple delay things, like the spy sound delay. Things with delays is that delays are very efficient. Even with small computers, our telephone can do delays, but what if you made multi-tap delays with a lot of delays, one after the other? What you will be getting is a reverb or some sort of multi-tap thingy, which is kind of strange, but you can make very interesting phasing effects out of that. And what I've done, let me open this for you. What I've done, you can see on the right side, all the export formats that are available. C++, JavaScript for web, Raspberry Pi format, audio plugin that can be VST audio unit for Mac or Windows, or a pure Max MSP external, which makes it incredible. You can actually turn your Max patch into an external, meaning that if I do something, I can actually make a very, very low and very efficient code combined in a Max external for you guys. I could compile this whole patch that you're seeing inside a thing for Mac and Windows. So all of us could use it. So as you can see here, there's a gen object, and this gen object is actually reading codebox. This is the DSP. This is my multi-tap delay code. It's very simple, very efficient. It's embedded inside a huge patch, and all these parameters are the controls, but the DSP is inside here. So DSP is not very, very complicated to write, but it's the interface that is complicated to write. This is why JavaScript, or if you're into Python, even Python is better to interface with that. And these are the nice improvements inside Max. These are really the nice improvements that happened along there. Even when Max 6 arrived, you could do some gen patching, but it was kind of buggy. And now that Max 9 has arrived, I find it lots of fun. But my whole purpose here is not to play with Max. It's to make some gen patches or rainbow patches inside the Raspberry Pi, or some plugins that I give to my friends that I can use inside their DAW, inside Live or Ableton Live or Reaper. And that's lots of fun. I'm making my own plugins thanks to that. And it's super efficient. If I can talk about something, because this is my whole purpose, is that all these tools, of course, Max, you have to pay for it. Gen is an add-on that has to be, that's inside Max, but Rainbow is something you have to pay for, which is, if we think all in all, if the whole purpose of patching and making DSP is for people to play with it. But if you have to pay a lot of money to use it, well, people who don't have that much money cannot use it, which is not very interesting. So, as I told you, I work with Graham a lot. And Graham has been developing, probably some of you know that, a programming language which is called, that's called Faust, F-A-U-S-T. I'll show you a screenshot afterwards. And Faust basically is a very simple way to write DSP code using mathematical objects. And then there's a server, and you can write that on the web. And then the web server will encapsulate that and embed that inside your destination platform. So let's go and have a look at that. I'm on Google Chrome right now. I'm using, I don't know if you can see when I'm zooming in, or is it just me? Right. Yeah, so faustide.gram.fr, probably write just Faust Gram. And basically, this is the web interface where this is the Faust code. As you can see, this is a delay, a stereo delay. It's very simple, and there are lots and lots of effects, filtering, things for the Bella, reverbs. All these things are available, and it's open source. Once I run the code, which is interesting, it is going to do, and this is the very beginning of what I was saying, is going to draw a diagram, a sketch of what is happening inside the DSP. So it's this diagram, when you click inside, you can actually see what is happening. Some things are added, going inside a delay, it's going out, and it's fed back inside a multiplier, then it's fed back inside the delay. This is a delay with a feedback. It's very simple. If you click inside, you can see there's a controller. Then there are several different things. So you can see you can get really deep inside the plot diagram of what your DSP is doing. And the fun thing is when you export that, I hope it's going to ask for it. Let me do this with this. Oh, there we go. I can export that for a whole lot. Let's call this delay. Lots of different platforms. Come on, compile. It's having difficulties to compile. Let's redo this. Run, there we go. Export. I'm missing something. Anyway, in this thing called platform, I could actually export everything in lots of different formats. C-Sound, Super Collider, Max MSP, Bella, Arduino even. I could actually export that DSP, Teensy, do lots of different exports. What what I'm heading for is that this code over here, this echo thing, I actually exported that inside Max MSP, inside. Let's find it. Where is it? Delay. Hard drive. It's probably still in delays. Forgot to highlight it. Yeah, there it is. There it is. Sorry, it was on the other screen. This is Rainbow again, but this code box thing is an export from the FOST code. As you can see, it's longer, but readapted for Max MSP, which is kind of interesting. I'm embedding some FOST code inside some Max MSP. This FOST code, you can find it on the internet. It's open source. And the way I talk with it, I didn't put lots of controls. I put feedback, interpolation, and delay time, which is fairly easy. It's just a stereo delay. But this can be described very easily. Meaning if I pass away, if Max MSP disappears, you can always, if you've written it down, if you've made a sketch, if you have a block diagram like this one here, you can always explain what's happening. This means that we can continue working with pieces and not always depend on Max MSP, because as much as I love Max MSP, I mean, I'm a huge user of that. Obviously, I do lots of Ableton Live and Max for Live patches. That has a downside to that. I do a lot of, pure Max MSP stuff, but how do I describe what's happening? How do I describe the DSP? How do I describe the calculation, the interface, things like that? Well, my solution right now are basically these three things: sketching things, using open source descriptions or like JavaScript that people could easily understand. A web developer will read it and say, yeah, I can read that. It's you learn that in high school here in France, JavaScript, so why not? And using some obvious, fairly simple open source code like FOST. Or you can use, and perhaps some of you are using Super Collider or C-Sound, you can actually execute Super Collider with C-Sound inside Max very easily, which makes it, basically you can embed anything into anything. And all in all, you can, of course, make your own hardware out of that, which is a lot of fun. For me, it's a lot of fun, meaning that I don't always rely on my computer because, computers break. You didn't do the correct update. It's not working anymore. My Raspberry Pi, when I turn it on, it's a multi-effect. It always works. And I've seen lots of people making some very crazy effects with Raspberry Pi or Daisy Seeds, which is another microcontroller, using Gen or C-Sound. And these work always. You can make guitar pedals, synthesizers. Meaning you can write your own piece, an entire piece with that, and you just give the hardware. This will never break. Your computer will certainly break. That's true. In 5 years' time, you can probably send it into the trash bin because if you haven't updated for max MSP. So that's my whole point, is how do we resolve these problems? Speaking of music and not speaking of computation, because we are stuck with computation and we're not the ones who are deciding that. It's, it's GAFA, it's the Silicon Valley who is doing that, which is nice for us. We have lots of new toys, but yeah, it's still not music. It will not, persistently continue over time. So I don't know if I was clear enough, or if I went perhaps too quick, or if you have too quickly. If you have any questions or remarks.
Audience, do you have any questions for now? Would you like to ask something? Yes. So we need mic.
Yeah, no problem.
Hi, thanks a lot for the presentation. It was wonderful. Thank you very much. I'm really interested in interfaces, and you've shown us the diagrams that you write, and I'm interested. Where do you draw the inspiration for the interfaces? Because for me, the visual state is really important. So you draw things, and maybe you get this inspiration from looking into new technologies, and maybe like in technological stuff, maybe in nature, maybe in looking at the musicians performing. So where do you draw the inspiration for interfaces?
It's that's a nice question. Well, I come from this very low-tech background, probably because for economical reasons, growing up in the 90s, where I didn't have much money. So this is why I went to synthesizer, because in the 90s, synthesizers were cheaper than computers. I used to have very, very minimal interfaces, and I like that a lot because aesthetically speaking, I'm more into the vibe of people like Karsten Nicolai, Ryoji Ikeda, this Mego scene from Austria, and very minimalistic interfaces. I'm really interested into that. I don't like when it moves a lot also. So this is one of the very simple interfaces that I use, and I try to make them as handy as possible. Because as I told you, I'm a performer. When I write music and when I do music, even with other composers, most of the things I do, I perform them, and I have to have them, within my fingers. So this means that the interfaces should be really clear. This is a very round, very big button because you need to, go and touch it. There's a smaller button because every once in a while you just touch it a little bit, but not that often. This is one of those things. And also because another thing I didn't tell you, but I read a lot of comic books and I like drawing a lot. So this is also an influence, comic strips and, books. I don't take that from nature, from graphical arts mostly. This is also part of these very minimalistic scene where you have a small waveform, very pure, very lots of contrast, black and white or black and blue, something very simple. I like it like that, not too much information. It confuses me. Also because I actually tend to make really crazy complex patches. I just sort of lay things on top of each other, and I can have something like 90 or 100, and my main patch has 110 effects overlapping on top of each other, which is crazy complicated. So if I want to play with them, I can't have them all open at once. I need it super simple. And for them to be simple, I had to think of a very simple way where I had the information I need. This one is on preset 1, this is on preset 2, and there's one knob. And that's all. This is the frame where I work in. This is why I like to keep it simple. I don't know if I have answered the questions.
Do you have any questions? I think no. I have a question actually. Maybe it will be difficult question, but can you please maybe explain the difference between research approaches of Graham and IRCAM about their maybe context or concept of the sound, their visions? Do they have such one?
It's a very interesting question and very complex one. But for you to understand the very big difference that are between these institutions, IRCAM is probably the biggest institution for electronic musician in France. It's not probably, it is by way, because it has different political goals. It sits on something very specific in France, which is fine arts. It's very close to Centre Pompidou. Probably you know about this place, which is a contemporary art center. And IRCAM and Centre Pompidou are the same thing in a way. But it also has a mission. It has 3 different missions. It also depends on the Ministry of Science, which is very small, called CNRS in France. And they have lots of fundings on that part. So they have this obligation to work on acoustics, on sound for rooms, and this is where convolution comes in, where very complex computation comes in, but also augmented instruments, sensors. They have lots of lines of budget inside that part. Whereas Graham is a more modest center, really more modest, nothing in comparison. There are other centers in France, but Graham basically chooses the goals it has. There is no political statement that says Graham should be working this research, as IRCAM has some fundings for this and this. Every time Graham is working on something, they have to ask for fundings if the government is interested in giving money for that. So this is very important, because if you work with IRCAM tools, you know that many IRCAM tools are proprietary tools that you have to pay for. Graham tools are absolutely free, which makes a huge difference, because open source is one of the fundamental ideas inside the Graham Research Department, which is whatever you do should be shared with everyone. Otherwise, but of course, whatever is shared with everyone doesn't, there's also a copyright thing where you make good musical ideas. You don't want everybody to have them. Or do you? I don't know. It's a trademark is a very complex question. I can't answer that. But the IRCAM is very specific about that. Some tools are trademarked. Graham, they don't. It's given. Faust is an example. Whatever research is done in Graham is given open source. And I very easily give my patches, because my ideas are very simplistic. It's not the thing. It's not very complex. But I never give the score. When I work with someone, I can give the patch. I always ask the composers if I can give the patch to my students. They can use it to play some music, but we never give the score with that accompanies the patch, because if you have the score and the patch, then you can redo somebody else's piece. So it's 2 different things. So this is basically the main difference. Is IRCAM is way bigger, has very clear goals in terms of research that they have to basically obey to, which is really interesting, because they can achieve some great issues like multi-channel spatialization. In IRCAM right now, there are more than 128 loudspeakers in a room. When you want to do ambisonics, I mean, there's Montreal, who has the same system. There are not that much systems around the world. IRCAM has one, and it's for contemporary music. It's not for pop. It's for contemporary music, which makes a huge difference for us, for contemporary art. Graham doesn't have that kind of money. It's way too expensive. And they have budgets in IRCAM to make that work, which means that, things are going on. But on the other hand, Graham is giving lots of tools. And right now, just to give you an example, Faust is heavily embedded inside Arturia plugins, or Rowley, Probably some of you know these brands, Arturia and Rowley, which are famous brands for instruments. And you have FOS code that's being executed inside that. And so when you buy an Arturia plugin, there's probably some FOS code inside, which is great. But Graham is not touching any money out of that because it's not the goal. I don't know if I'm clear about the whole thing.
It was great.
I lost you.
Yeah. Если у тебя есть вопрос, задавай. Тоже? I'm sorry.
Yeah.
There was some problems with microphone, but thanks a lot for your answer. I wanted to ask another question about the sensors that you were working on. Maybe you can use some example of one of the projects. I'm really interested in how do you let me explain about the limitations that you set, because you said that you sometimes like to use 10 effects stacked one upon each other, and in sensors and when you are working with performers, I expect that there should be some robust system, right, that uses uses the gestures of the musicians and and there are not so many parameters that you can change with those gestures. So can you explain with some example maybe how do you approach those systems? Thank you.
That is a deeply complex question because it depends on mostly the aesthetic of the pieces that's being performed and the quality of the sensors. To make it very simple, well, sensors have gotten very far right now. We have, crazy sensors. I've worked with lots of them. There's, I've been doing, first of all, my own sensors with Arduinos, and it's fun. But at some point, it's not enough. So you can find on the market lots of sensors. There's a French brand that's been around for some time now called Interface Z. They do very robust and simple sensors that go MIDI. It's basic MIDI. So this was my first sensors that I bought that made it easy to understand, like switch, bend sensors, detection, distance sensors, accelerometers, magnetometers, stuff like that. But they're kind of buggy. I mean, there's lots of noise inside. So to have good sensors means, you need to put a lot of money inside. Some time ago, there was this brand called Riot, RIOT. They've closed right now. It's a former researcher from NIRCam who worked a lot with sensors. He did this brand, and now he stopped doing sensors for art. He's been doing sensors for medical tech. And this UK brand called Ximu is doing incredible, XIO is doing incredible sensors that we've used with Alexander Schubert on the piece we did in September. And the main idea was not to map one parameter to sound, but to map that to a system. Let me explain. Let's say that you have 2 or 3 axes of dimension, a tilting, pitching, and up and down or rotation. What if these parameters were actually inside a 3D model? And every time you scratch this, you go like this, you will scratch a surface that is a resonator. When you go upwards, you're scrubbing through sound. So if you do this and this, you are going to both scratch and scrub through a sound. So you see, I'm mapping a 3D dimension object that's rotating like this to a 3D dimension musical system where I have embedded some, things. I'm not using it as a slider that's going up and down and just scrubbing. Sometimes yes, sometimes no, but sometimes it's actually modulating 3D within a 3D space, multiple layers of parameters, which makes it really musically interesting, but sometimes really messy, super messy. But if we want mess, it's kind of interesting. So we did some things like let's say the velocity of a movement is the density of the grains in the sound. But the higher you go, the more resonant it goes inside. Model synthesizer with the string model. The higher you go, the more resonating the strings are. So the grains are sent inside a model resonator, and the higher you go with the hand, the more resonating, but a chord is being played at the same time, and the score is changing within the piece. So you can have some harmony going on. We did that kind of thing, which is kind of fun to play with. Very simple ideas, but instead of just mapping it one-to-one, it's embedding things on top of each other. Just represent space, and let's say you have a square like this, and on each side of the square you have effects, and the further you go, the more effect you have. Very simple. But if you do that on layers, then it gets really complex. But of course, if you want to cue and go through a story within a piece, you have to use a queuing system. And this was me queuing it. I'm not letting the performer cue it. It's too complicated. I prefer to have it structured. This is because the piece was structured that way. I find it more reliable. But I know that some people do it, but I don't know how they do it, unfortunately. I don't know if I answered it correctly. But, okay,
Yeah,
great,
thank
thanks.
you. Yes, and we have another question. Yes, please.
Добрый вечер. Расскажите, пожалуйста, про ваш опыт взаимодействия с роботами и какие вы можете привести примеры применения роботов в музыкальной композиции.
So I will translate. Do you have experience of working with robotics? And do you know maybe some examples of musical pieces with such kind of sorts of things?
Well, no, I don't have much experience with robots. I mean, the production I worked on with Alexander Schubert here we had 6 or 7 robots, different robots, but I wasn't involved in that. I was actually involved in using the sensor that were remoting the robots. A performer had a sensor on his hand, and the robot arms were moving according to his movements. And I had to map his movements to the robots. But I didn't program the robots per se, because this is really engineering stuff, which is beyond my capacities. But when it comes to pieces with robots, there's a, and I can't remember the name, there's a very famous piece by German composer Heiner Goebbels. Heiner Goebbels, a very, very famous piece with pianos being played and strummed, and mechanics going all around. And this is done according to a MIDI score. It just sent with the Logic Audio is sending MIDI over, and all the MIDI is transformed into robotics, which is really interesting. There are lots of pieces using that. There's a famous French artist who does very minimalistic things called Frédéric Leginter. He did things with very cheap Arduino things that go in hit stuff. But this wasn't remoted with digital processes. It's all analog with mechanics turning around. There are lots of pieces using that kind of technique, actually. What can I think of?
You know the piece by Georges Apergis?
Oh, yeah, of course. Yeah. I'm losing the name again. I ran into the thing.
Machine music or something like this. I don't remember.
Music machine.
Yeah.
It's music machine. I think it's music machine. I have that in my audio library. Yeah, music machine is one of those pieces that uses lots of MIDI to control mechanical things. There are lots of pieces using that, or with less instruments, you could do that with. I did this piece by Clara Iannota many years ago when we used, and she actually had that developed at ZKM. I didn't do anything with that. With small robots inside a piano that were hitting the strings and vibrating. And this was all the remoting came from Max MSP, and that was pure MIDI turned into motors. And it's very cheap to do. Actually, it's very simple to do, and you can achieve a lot of things with that. Which is, I think it's really fun. Basically, the thing I do with my my noise box is that, but I'm not sending MIDI. I'm sending control voltage, but it's basically the same idea. And because right now analog synthesizers and modular synthesizers are absolutely everywhere, you can find code with MIDI to control voltages over internet. It would probably cost something like €5 or €6 to build it, and you can, with that, you need to, of course, adapt power, and you could probably control motors or hitters, sticks. It's very easy to do, but I don't have that much experience in to do that. I use Arduino to do that because it's cheap.
So do we have any questions? I think no. So I would like to thank you for coming for our conference and for your beautiful presentation.
Thank you very much.
So I hope we will meet in future. So thank you. I think, and we will perform your pieces, of course.
Thank you.
We'll be happy to perform it. So thank you so much. And for our audience, I will say in Russian that today we will have program 2 because on Thursday and Friday we will have last conferences day. So please visit our website or our social media to check our schedule and to choose the events that you would like to see, to watch. So thank you for coming. And so for now.
Thank you very much for having me, and have a good time. Thank you so much. Bye. Goodbye.